happy return to the videos. So this is a video still related to kind of areas, perimeters, which we have done, but it's a little bit of I guess a bonus on trying to get you to think about maximizing the area of a rectangle. So you see the area of the rectangle, let's say length and width, you can call it base, height, whatever you like, from a given perimeter. So what if we were trying to construct a rectangle and we were trying to maximize its area and we knew what the perimeter was? So first, let's write down here, the perimeter is equal to 2 times the width plus 2 times the length, right? Because we're going all the way around. Now, if we know these two values, then we can clearly find the perimeter and we can also find the area. So the area itself, area is equal to, this is just simply width times the length, or length times the width, or whatever it may be. That is it. Now, if someone gives us what the perimeter is and does not give us the width and the length and asks us, well, try to construct the rectangle in such a way that your area is maximized. What's the maximum amount? Now you might think, so how do I do that? So this is a pretty neat little problem. And I'm not going to use any calculus or anything like that. I'm assuming you're just in grade 9. So what we're going to do is we're going to try to kind of isolate for one of the sides. And then we're going to plug it back into the area. And then we're going to try to find points. All right. So we're going to start off, with the, let's say, the width or the length, and then seeing what happens as we keep increasing that width or length. So let's do that first. So I don't think that anybody would argue that we can isolate. So let's say P, say this is 2W plus 2L. I'm going to pick, so I'm going to just pick arbitrarily. So let's say that I wanted to isolate for, let's say, W. All right? So I wanted to isolate for W. And now, so that's going to give me, so I'm going to have P, I'm going to bring this over to the other side. So this is minus 2L is equal to 2W. Now dividing both sides by 2. So if I divide both sides by 2 here, so that will cancel. And I'm going to get that my width is equal to P minus 2L divided by 2. So you might say, okay, so what's the big deal? Okay, so you have W. Now, keep in mind that I'm assuming that we know what the perimeter actually is. And I'm going to give you an example. But first, just wanted to show you that you can isolate for whichever variable you want. So in this case, it's W. And then that would be just simply perimeter minus 2L divided by 2. Great, so we have that. Now, what is the area? Well, we know that the area here is simply equal to, so as we said, this was just length times width or width times length. But if I isolated for this W, I can substitute this back inside of here. And as I substitute this inside, so I'm going to get L, let me put P minus 2L divided by, all right, 2. So doing that, so this just simply equals, I can bring this L inside of the brackets, I can multiply this through, and that would give me simply P multiplied by L minus 2, and now notice you have L times L, which is going to become L squared, and all of this is divided by 2, and that's my area. All right, so it looks kind of weird, but notice that there is a squared. So now I can basically play around with the area, okay, and then see what happens as I'm changing my L, my length. All right, so my length is the bottom one here. So what happens as I keep changing this around? What's going to happen to the area? So what I like about this is that if they give me the perimeter, then I can just substitute the perimeter, and all I have to do is just change L to see what my value for the area is. What I'm trying to do is I'm trying to maximize this area. Maximize. So I want to see if there was a value of L that it will maximize that area. Okay, so let's try it. So this is what we're going to have. All right, so I'm going to take, all right, so here, let's say I'm going to do a little table of values, L. So let's say that. I'm going to divide this up, all right, like this. I'm going to try to find my area. So here's my area, and I'm going to use that equation to try to find. Okay, so what that area actually is. Now, we can take any perimeter we like. All right, so if the perimeter is given, say if it was 40, all right, meaning 40 all the way around, it can be in centimeters or inches and meters, whatever it is that you like. It can be 20, it can be 10, it can be 100, it doesn't really matter, all right? So I'm going to pick, so let's say arbitrarily, okay, so let's say that my perimeter is 40, all right, so that is my perimeter. So now if that's my perimeter, so that means that I have, so my area equation, so area now equals to, so this is 40L minus 2L squared divided by 2. Now the 2 actually can cancel these out. So what you would have is, okay, so 40, so 2 goes into 40 20 times, so this is 20L. And then minus, this will just become L squared because that 2 and the 2 will cancel. So that is basically my equation. All right, so let's walk through it. So if my length is 0, all right, so then I don't really have a rectangle at all because there is no length, right? So notice if I substitute 0 into the area, I clearly am not gonna have any area at all. So if I substitute 0 into this equation. Now, and I'm going to just kind of walk through this. So let's say I substitute now 1. If I substitute 1, so what do I get? So I'm going to do just kind of one of them for us. So here, notice, so this is going to be 21, and this is going to be just 1 squared. So this equals 2, so this is 20 minus 1, which is equal to 19. So this is 19, all right? So that is with L equal to 1. Now what happens if I now continue doing this? So if I say 2, okay, so what happens here? And I'm gonna kind of speed up the video from here as I do those calculations, okay, so that you're not kind of wasting time. You can try it on your own as well, all right? Okay, so see you in a speed up video. Let's go. All right, so welcome back. Okay, so look what happened. So we were just constantly changing. So notice we got area of 0, we got 19, okay, 36, 64, 96, okay, 100. So notice we're just kind of going. Now, if we plot this, okay, so what we're going to do is, if we're going to plot it, so if you have, so you have done some plotting, all right, so let's say if I plotted it up, okay, so I would have something like this, right? Let me go back here. Actually, this is all positive, so go back here. Okay, so this, let me blow this up. Okay, so this is your L, and this is your area. So notice what happens. At 0, okay, we're stuck at 0, right? Notice at 20, because that means the length was 20, that means the width had to be 0, right? So there was no width in that case, because you had length of 20 and 20, which was 40. So that's would have been the perimeter that would have collapsed the rectangle. So that means at 20, so right here, we were also, okay, at 0. And now, as we plot these, notice it goes kind of 19, 36, 64, 96, 196. So notice that it peaks at the halfway point there. So it goes basically like this. And what happens is, as you plot this along, okay, and you're changing these up, okay, you would have gotten something like that. So there is a peak, which is basically your maximum right here. Your maximum was 10. So when you're doing and you're given a perimeter and you're trying to maximize your area, it turns out, okay, so notice if I do this, so this means that, okay, so this was, sorry, we screwed this up here. This was 100, okay, in terms of the area. Okay, so this is the peak of L. So that means if you take your rectangle, basically the L is going to be 10, which means that your width is also going to be 10. So it turns out that in order to maximize your area given a perimeter, then basically what happens is, and you can try it with many other perimeters, is that the maximum length is going to be equal to whatever the perimeter is divided by 4, meaning all the sides are equal. So a square maximizes the area. And you can see that happening. And right here, this is if we were plotting it through. So notice I can actually plot it. You can take whatever it is that you have. So I'm going to plot it. I'm going to use this amazing duodecimals here. So the area equals, and we had, let me just go back here. It was 20L minus L squared. So this was 20L minus L squared. Oops, this is L squared like this. And notice, so if I go back here, all right, so notice that the maximum point there is 100. That's the top area. And indeed, this is like a parabola, which is pointing downwards. So in your future classes, grade 10 and 11 and so on, you're going to be talking about these parabolas. And that peak is your maximum peak, which is basically kind of the half point, all right, between 0 and 20. Or you take your perimeter and divide it by 4. Okay, so give it a shot. Okay, we'll see you in a future video. Bye, Niner. Take care.